Some vocabulary you're going to want to know this week. Make sure you know what an angle is. Remember, it's the interior of two rays, and we measure angles in terms of degrees. You want to know what a vertex is. A vertex is a common endpoint. The multiple vertex are called vertices. Every angle has an interior and an exterior, which should be pretty obvious from the shape of the angle. Here is our interior. Here is our exterior. Right here is where we measure. Here's our vertex. That's what an angle looks like. To measure an angle, we typically measure in degrees, and what you want to be thinking about is we're measuring in degrees of a circle, which looks like this. Okay, there's our circle. And so when we're measuring an angle, we're measuring it as a portion of that circle. Oh, that's not a good example. Let's try that again. Make sure we get our center point. There we go. As a portion of that circle. And if we recognize that circle is 360 degrees, then our angle is whatever portion of 360 degrees that takes up. So that's how we measure it. You can also think of it, 1 degree is equal to 1 over 360. Just like our ruler postulate, we have a protractor postulate, which essentially says, hey, protractors can measure angles. Seems pretty obvious. We have a couple of different kinds of angles. I'm sure you've seen these before, but just a reminder, acute is less than 90 degrees. Right is exactly 90 degrees, and it's always marked by that little box in the corner. Obtuse is greater than 90 degrees up to a point, and that point is the straight angle. The straight angle is 180 degrees. So this is acute, right, obtuse, and straight. Good. If you have an angle, you can have what we call an angle bisector. And just like you would imagine that we've seen this word before, this bisector word, well, this is an angle bisector. So what does it do? Well, it cuts the angle in half. So if we were to label this, let's say L, J, K, and M, we could say that angle L, J, K is congruent, to angle K, J, M. It's important that J is in the middle of both of our angle names because it's the vertex point, so just be aware of that. Along with angle bisectors, another important postulate is what we call the angle addition postulate. Okay. The angle addition postulate states that if there are two angles that share a side, like these two angles do, that we can say that if this is A, we'll call this B, we'll call this C, and we'll call this D. We can say that angle ABC plus angle CBD, so this angle and this other smaller angle, okay, they're not necessarily the same size, they can be different sizes, are equal to this total angle, this whole thing from top to bottom. We call that angle ABD. Okay, so let's use some of our information. Let's just practice a problem real quickly. So here we have measure of angle XWZ. So that angle is this full angle here. That is going to be 121 degrees. And the measure of XWY, that's just this angle here, is 59 degrees. And we have to figure out YWZ. Okay? So this goes along with our angle addition postulate. So if we think about how that sets up, what we want to say is that the angle XWY plus the angle YWZ should equal XWZ, angle XWZ. Then we can do some substitution here. So if we were writing a proof, we would say this is angle addition postulate. I'm going to use a short form here. And if we were writing a proof, our next step would be substitution, and we would do that by knowing that XWY is 59. We don't know this one, so we just write angle YWZ still. And we know that that equals 121. That's by substitution. Okay? Just like we're doing a proof here, okay? So the next step would be, okay, if this is a proof, what's the next line? The next line is doing subtraction property of equality, subtracting those two from both sides. We call that subtraction property of equality. And now we're left with angle YWZ equals, and then we do 121 minus 59, which is 62 degrees, which is the answer they have here. So we're good. And that would be QED. That's what we're going to write at the end of our proofs to say, yep, we proved it. Okay, that's just an example problem.